K5RWK. And the part of the hobby I like is building antennas.
Yeah.
So, and the other thing is I like to use PVC, as you can see from the pole here. But when K5RWK got their new fusion transmitter, just like the presentation ahead of us, we needed an antenna to talk to these guys. I hadn't built an antenna for a long time, and I decided that I was going to try and come up with a unique antenna. And this is different probably than any antenna that you've seen. Long periodics and Yetis work real fine, but they're boring. Oh, sorry about that. But anyway, go ahead. Now, why would I do this? Well, RWK just installed a new 70-centimeter repeater, 441-375. I'd not designed an antenna for a long period of time, and I thought I might do something different. So what this is a direct coupled dual rectangle beam for 70 centimeters between 440 and 450. And the basic geometry of this guy looks like, I don't want to do some rain, but I don't know how well you can see this because it's thin wire. It is not a mobile antenna. Okay, go ahead.
Is that like a fly swatter?
It's going to be. Okay, now, but this is this, you had that, where's your pointer? Oh, in my, here it is. I'll use this one.
Another good use for antennas.
That's right. But, this is two rectangles. This is a reflector. Here's the director or the driver. And these connect the two elements together. Now, if you look at this thing, it's one single element, or one single construct. It's connected together. And go ahead. Now, originally I made this out of 14 wire. You can think this is thin. Got a little crooked here. 14 wire is even smaller. So I went up and I got 12 gauge wire. It's the interesting feature of this antenna. It's both dual rectangular elements, electric connected, so that strictly speaking, this is a single monolithic antenna. This was designed in a way to make it easy to put on my piece of PVC. It's good. I used N4 NEC2 to optimize it for front to back, and I wanted an SWR of less than 1.3 to 1. Now this is a new design. I started this in November, and I spent 3 weeks optimizing it, just trying different things, and that's why I came up with this sort of strange shape to it. An attempt was made to take into account the effects of the feed line radiation, and so this is a direct feed with no balance. That was the other thing I was trying to do and get done with this one. So we'll see what happens here. So now, what the NEC produced was this ARR style radiation pattern thing. And they predicted that we'd get between 15 and 20 dB from the back on the thing here. So go ahead. And the SWR is right here at 444. It's the lowest I could get it. So this is where I was shooting for. Now I'm not after absolute best you can, this is the best I can design it to, but all I was after was an interesting antenna that was interesting to build, and it was fun to design. Okay, now here's the impedance down here, and 444 is about 50 ohms when you get, go ahead. So now, here's what the antenna looked like. Now this is the first shot. I forgot, I tore that one apart, and then I forgot to take a picture of the second one, but this is the second one. But basically you can see, because you can't see it over here, here's the reflector, here's the thing, here's the two braces to hold it, so I can support it right there with my PVC, and right here is my direct feed on the thing. Strange looking machine. Go ahead. Now notice the coax is directly connected here. There's a little gap right in here. It's supposed to be, didn't carry it in the car and stuff. And it was taking this feed line into account, so I didn't have to put a balun with it. Balance with that.
Shield on the coax connected to anything?
Yes, the oscillator of the coax is connected right up here, and the shield is connected right there. And there's about an 1/8 of an inch gap
Between?
right in here. And you can come up and look at this.
There's actual physical gap.
There's an actual physical gap, yeah, it's not connected there. Okay, go ahead.
Oh,
Now, unfortunately, I didn't have any professional equipment to test this thing with. Okay, I used my little, this is my signal generator. I got this, I got actually one, this particular one at the Plano Christmas dinner. And all I have is this homemade SWR meter, field strength meter, excuse me. And so I was going to try to do this. Now, when you build a field strength meter, you got to be sure it's in a metal box. I built one in a plastic box and done like red beans. But anyway, so the next thing I did was I set up a test area to test this thing in. Now, I tried several ways of testing it, and go ahead. And what I really came up with, I changed field strength meter because this little Radio Shack one really wasn't doing what I wanted it to do. But what I did is I found out from the center out at from this point, how far I could move out and make full-scale reading on my meter. So that gave me a range, that gave me a full scale of 10 units, whatever it was. So I drew a circle with the radio in the middle, the antenna in the middle. Then I decided, well, I want to make about 16 measurements around here to see how I'm doing. And so what I did is I just divided this circle up into, eighths. I got 16 locations around the circle. And I set up my non-conductive ladder.
yeah.
Okay, the wooden one broke, so I had to go out and buy a new ladder. That comes up. And I tried basically to set the antenna and the field strength meter at the same elevation. So I was not measuring down here or up here. So I tried to make it about this. And this is actually about that far when I took the measurements on it. So the first thing I actually tried, and you can see here, is I tried to put a piece of PVC in here and rotate the antenna and try to measure the angle of the PVC. Well, that came out real weird because I didn't have any place neat to put my compass. If you put the compass out here, it's not really going around the center. You put it up here, and it falls off and wiggles. And so I figured that this would be the easiest way to do this. Go ahead. So, after measurements and plotting and stuff, this is the actual plot I made of the output of the antenna, which looks pretty close to what I actually predicted it would do. For some reason, and I don't know why, this part of it is screwed over here. And I went back and redid the measurements on it again, and it came up the same. So I got something that's just not square in the thing. So, and I estimated that the error in measurements was about 1/4 of a number error in the thing. It's about as close as I could read the meter. Now this is, what I had to do was I made a little trigger to turn the radio on. It just lay on the ground. And I'd push a button, and then I'd go out there and measure what the SWR meter said. And this is basically how I did this. Next. So it would have been nice if I had a reference antenna or somebody to find out what was happening. So I just took the radio, put it in the same plane, and keyed it with this antenna. Supposedly this is a high gain antenna to sell with it. And the best I could do was 1 unit on my field strength meter. So for omnidirectional around this thing, I got about 1, a little bit less than 1 on it. So this is sort of how I tried to validate my measurements that I was doing in the thing. Now this is all done in fun. I mean, I'm not sure how well this would stand up in a windy situation, but it'd be fun to build one and stick it out there for a while and do this. Yes?
Could you make that out of copper pipe? Small diameter copper pipe?
Well, you probably could. I've also got some very thick copper wire, about 1/4 inch in diameter. Yeah, and I've got a spool of it that I bought someplace. But when I made this antenna and I designed it, constructed it, I came down here, made a right angle bend with the wire I had, came up here and did a right angle bend, came over here, all the way through here, made a right angle bend, came down here, and all the way around. So this basically is 1 wire to do that. Now trying to bend that real thicker, 1/8 copper wire was just a bugger.
Well, the military, on their old telephone systems, had a reflector very similar to that, and it was made, they call it a fly swatter antenna, it had a dipole antenna on basically a ground plane.
Yeah.
Yeah, and that's very similar.
Yeah, I've looked at some of the Yankees that they have, and they have a reflector that's like this, and then they have the Yankee out front, which is a very successful antenna. But I wanted to try something different. I wanted, just to screw around with this and see what happens with this thing. Excellent. So it was that I just wanted to build another antenna. I love building antennas. I build 1 a month, maybe. A while since I wanted to design a unique antenna, something that looked different, but would give some good results. I could feel not good about it by taking it out and trying it and stuff. We actually, the Metrocrest Ham Club meets over at the Whataburger at George Bush and Old Denton Road, which is below the ridge that runs between Richardson and Carrollton. And we're able to hit, with this antenna, we're able to hit very successfully the fusion antenna that we have here. And it was full quieting, it worked good. Didn't get anybody to talk to me yet, but so, I wanted to test and figure out how to test the antenna. I mean, it'd be fun to take this antenna and sort of set up, the one that you're working on, and sort of set it up, because you could validate it without a lot of complex, antenna stuff. You probably have your circle about 50 feet out, whatever, but and it should be able to, you should be able to plot front to back and see about what kind of gain it would be, and it would be interesting to try that and see.
I know some people at Agilent, I'll make a phone call.
Yeah, well, guy up in Denton's got a real nice vector analyzer that will measure antennas too.
Bill, there's the DNA right here waiting for you when you're done.
Oh, okay. That looks good. And I just wanted to see if it works as advertised. And it was a lot of fun. Yes?
Is it a horizontal polarization?
Yes.
So if you turn it on end, you get vertical.
Yeah.
Okay.
Yeah, it didn't work that, actually I was able to hit,
Are the repeater here, are we using vertical or horizontal polarization?
we use vertical.
Vertical.
Yeah. And I just wanted to see, there's 20 dB difference between horizontal and vertical, but we were able to take this outside the Whataburger, which those people over there, we get 25, 30 people there, and we take antennas out there, we put up buddy poles, I mean, they just love us. And we were able to hit the repeater pretty quickly, and so there's quite a bit of gain on the antenna. Any other questions?
What club did you say it was?
Pardon me?
Club?
The Carrollton Club. Yeah.
is a copper wire in between the radiator and the reflector. Do you see any current there, or it's just a supporting? Because if it's a quad type, usually the both ends is a maximum current. So connecting.
Yeah, but this one, this is a little bit different because it's actually got two loops here, both of them. That's why we get a little bit more gain. And I didn't simulate I didn't put the simulation, but the pattern looks like this. You know, it looks like a regular beam antenna rather than a vertical. It's still, if you did this way. But mounting it this way was easy, just cut a couple slots. Yes?
The dimensions of those, are those like four-way loops, or is there a, what is it in relation to the wavelength in terms of the size of those
I forgot.
squares?
I knew somebody was going to ask that, and I forgot what the dimensions. That's about, this is 14 inches here. So it's,
Okay, 14 divided by
Would you have any ambitions of making one of those for HF?
pardon me? Yeah, no, it'd be pretty.
Well, changing the mechanics and the strength of it a little bit.
Yeah, I'd probably have to use 3/8 inch copper tubing to do that kind of stuff. But I just thought it was a unique way to try a different antenna and see what was going on.
So you get them out or on your house?
No, this is it. And like I say, the only time I've really tried it was when we took it over to breakfast the other
What's your
day.
opinion of the front and back ratio?
Pardon me?
What do you think your gain is?
I don't know what the gain is. I didn't measure the gain. I was trying to a front to back ratio.
I figured it out here.
Well, it's 22 dB front to back. I measured.
Oh, that's what it's making then.
Yeah, and it, like I say, it will not probably stand up under high, as it's built right now, stand up.
Problem is that, yeah, you can get by.
Yeah. There you go. Any other questions? Anybody enjoy it? Yeah.